Hi folks, DD Solar here. Some time ago I was searching the internet and I found a research paper about some college students who investigated the possibility of using diodes with solar panels to generate heat and do solar electric cooking. This got my attention. Due to health problems, I never got into the workshop to start looking into this, but finally today I will start small-scale research into the topic. My interest is not just solar electric cooking, but also PV to load solar electric heating. If you've seen my past video work, you are probably familiar with my converted space heaters, which operate on direct DC solar power, also known as PV to load solar electric heating. If you want to see more about that, please check the videos linked in the description. Unlike normal resistive heating elements found in space heaters, diodes are discrete building blocks, which are easy to work with. They can be assembled into a broad range of different configurations. Plus, they remain relatively stable over a variety of solar conditions, unlike resistive heating elements that allow the PV solar array voltage to fluctuate quite a bit, leading to lost power. Today in my workshop, I'm going to document my first venture into solid-state PV to load heating elements by connecting a bunch of large diodes in series to solar panels and measuring their performance. I will be using a mix of 100-watt 12-volt solar panels to test this concept on a small scale. What I want to do in the future is build a larger heating element which can run at around 55 volts DC and dissipate much more power. But first things first. Okay, let's roll the workshop footage. And I'm going to show you my small-scale attempt at trying to duplicate their work using a bunch of these diodes. Now these are just 20 amp diodes, nothing particularly unusual. They are rather large compared to the ones I have in stock. And I got these to attempt to try to make heating elements, solid-state heating elements, that I can run off of solar power for the purposes of heating my workshop or my home or whatever. Now I don't know how far I'm going to carry this idea. This is really just early research, and I just want to see if I can duplicate the research paper's work and see where it goes from there. To make a prototype, I've got these terminal blocks, and what I'm going to do is I'm just going to start connecting these diodes in series, and I don't know how many I'm going to need, probably a lot of them. The first test, I'm going to use the two solar panels outside my workshop, which is two 100-watt panels. There's quite a bit of wire between this workbench and those solar panels, but it should be enough power to test this concept to see if this is going to work or not. To get started, what I'm going to do is I'm going to take these 20 amp diodes and I'm going to arrange them on this terminal block. And I have several terminal blocks. And I think that by arranging them in this way, I should be able to get enough diodes connected and get some power flowing through them. Now, to make diodes work, the electricity only flows in one direction, so it would go this way. In order to make this heating element work, I've got to make sure and get the diodes the right way around. So all the stripes need to be facing the same direction. So I'm going to bend these diodes to fit this terminal block, and I'm going to see how many I can get on there. And again, I don't know how many it's going to take. I have about 80 diodes. If I remember correctly, I don't know if that's enough. It could take a couple hundred diodes. If I want to run at 30 or 40 volts, which is my future idea, it's going to take a lot more than this. Let me explain how a diode works real quick. A diode is a semiconductor junction inside of this package, and the way it works is the voltage is supposed to only flow one direction. In this case, I have all the stripes aiming the same direction. The voltage would come through here, and then it would complete a circuit. It can't go the other direction, but that's okay because we don't need it to. So what I need to do is get enough of these hooked up to drop enough voltage. A diode actually has a voltage drop. That means that when the voltage flows over it, yes, it does work, it does act like a one-way valve, but you lose some voltage. And that's just the way it is. There's no free lunch. If you're going to use a semiconductor junction, there's going to be a price to pay. However, because this diode drops voltage, let's say you have 10 amps going through this diode, if it's dropping, I don't know, a half a volt, that's 5 watts. So this diode, theoretically, would dissipate 5 watts of heat. And it has no moving parts, and the most exciting thing about these diodes is that they are semiconductor junctions, and so you can switch them in and out of circuits. Now that's getting a little ahead of things, so for right now what we're doing is just creating a simple prototype or demonstration rig to see if there's any merit in this idea at all before spending any more money on it and before putting too much work into it. I want to see just how much heat can I get from these diodes. Is it even really possible? And the paper I read did seem to indicate that it was. It's pretty interesting, but I have to see it for myself. Now I'm not going to bore you by showing you all these diodes being inserted into this terminal block because no one wants to sit there and watch that. So I'm going to go ahead and try to get one or two of these done, and I'm going to test them to see how many I need to make a heating element. And then I'll be right back with you. I'd like to start with more diodes, and if I need to, I can always remove some. I'm not really sure. Like I said, I have no idea exactly how many diodes it's going to take. And of course, I need to use a circuit board for this. I don't have a circuit board developed right now. These terminal blocks are like a prototyping board. They're just the easiest way to get these diodes attached to each other and try to do some tests on them to see what exactly they're able to do and how they perform. I do think this technology is really interesting, though, because it would allow you to create a heating element that was dynamic. Now, this is kind of like winding your own heating element, but it's kind of the digital high-tech way of doing it, I guess, because you're technically using electronic components to make a heating element. And I know this is very unusual. This is not something I've ever seen addressed anywhere or talked about. It was just a paper I found, and I found it very interesting, and I could not stop thinking about it. This is my attempt at replicating the research. Who knows where this will go. Now, diodes usually drop about a half a volt. However, that is not necessarily a stable thing, because the amount of voltage they drop can change and does change. Another problem is that diodes are known for shorting out. They can go short circuit. They can also go open circuit. But everything electronic, everything electrical has a failure mode or multiple failure modes, and there's nothing you can do about that. Guess we'll find out. Now, the total power available to me on this first test would be theoretically, it's two 100-watt solar panels, so you're probably looking at about maybe 100 watts most. I'm not really sure. And I don't even know what this is going to do, to be honest with you. I have no idea. Well, we have a total of 23 diodes here. I'm just going to go ahead and put some power into it and see what happens. I hope I got all the diodes in the right direction. And now the chore is to tighten all these screws. And there are a lot of them. And once again, the terminal blocks are not considered a permanent way of making a heating element. It just happens to be the fastest way that I can get these diodes connected. My hope is that if I like this kind of setup and it performs well, I might actually try to develop a PCB and put the diodes in that. Not really sure. Okay, I want to do some testing here, and I want to use some kind of an instrument so you guys can see the electrical characteristics here. I've got this watt meter. It's kind of used for RC planes and whatnot. I've got 21 volts going into it. This is just a first test. And of course I wouldn't run this off of solar. What I need to determine is what is the voltage that would be required to push power through this heating element. I really have no idea whatsoever. Alright, I hope you can see that. This is the output, so I'm going to use these alligator clips to make the connections. Alright, so I have my watt meter. I've got the power coming in here temporarily. This is just to test the heating element to see if it works or not. I hope it will. And I've got the output right here on these clips. Now for these diodes, this would be your positive. You can see the stripe right there. On a diode, the voltage goes this way. So it should go this direction. So that would be my positive. And the negative would be over on this side. Let's try about 12 volts. Wow, the display is hard to see. Alright, 12 volts. Well, it's about 12 volts. It doesn't matter. I'm going to go ahead and hook it up. And this is 23 of these diodes that I bought. I'm going to hook it up and see what happens. Okay, absolutely nothing. Something like 20 volts, that sounds more reasonable. Let's give that a try. Yep. So here's the first trial runs with the solid-state heating element. 9.7 watts. Now this meter is not going to be super mega accurate, okay? It's just a basic meter, but the bottom line is that I'm already feeling warmth coming off these diodes. They are getting warm. That means they're dissipating about 11 watts. So literally, what you see here, folks, is a solid-state semiconductor-based heating element. My intent is not to be running at 12 volts. It's to be running more around 50 to 60 volts. Alright, so I don't want to burn the diodes up. My plan was to use a fan on these, so let me go get a fan and hook that up. Okay, I figured that a fan would be part of this type of heating element, and I was right. I'm going to go ahead and implement a fan because I don't want to burn my diodes out. And what you want to do is take the heat out of the diodes and put it in the air where it belongs. In order to do that, I have to use a fan. 14 watts. Not sure how accurate this meter is, but I'm pretty sure it's enough for what I'm doing. Yes, the diodes are getting warm. Warm is okay, but stinging hot is not. And there's a balance. This type of heating element would most certainly require some kind of heat sinking or cooling to make sure that the diodes don't get too hot. Now what I'm going to do is introduce the fan to see how that affects the performance. Let's go ahead and power up the fan. The fan is running off of another 100 watt solar panel outside my workshop. And let's just let this fan run, see what happens. Maybe it doesn't affect anything, but I want to cool these diodes. And this fan is not blowing enough air. It's blowing some air, but it's really not enough. Let me try to find a more powerful fan. I'll be right back. Alright, here's version 2. I've got a much more powerful fan. And I'm pretty sure this fan should blow enough air. I'm going to turn on the heating element, let it warm up. 12 watts. I'm just letting it warm up. I haven't changed the voltage on the input. That's right here. This is where the input is. The voltage is coming up here, going in these diodes, taking a turn, and coming out the negative right here, depending on how you look at it. That's how I like to look at it. Let's turn the fan on and start cooling these diodes down and see what happens. A lot of air coming out. Yeah, they're still warm, but it is cooling them. It does not appear to have changed the dissipation much, if at all. Still 18.3 watts. And I hope you can hear me over the sound of the fan running. I think they're cooling off. Yeah, they're cooling off. And that's what's happening. They're cooling off and you can see the wattage is dropping. This is actually a good thing. It means I'm cooling them off. They're not going to burn out. Yeah, they're cold now. So as the diodes warm up, they drop more power, which is fine. Now I'm going to try turning the voltage up a little bit. And in order to do that, I have to increase the current. Let's increase the current. And we're getting almost 2 amps, something like that. 38 watts, so that's about twice the power. And the diodes are still quite cold. Definitely could push a lot more power. 38 watts, yeah, this is only a handful of diodes. I mean, I can double them. 38 watts. Let's see how high I can go. Let's try a higher voltage. It's actually the current. So I needed to turn the current up. $55 watts. Wow. 55 watts. And as long as I have a fan running, they're handling it just fine. Trying to see if these are getting too hot. So far, they don't seem to. My goal is to operate this heating element in a more advanced form off of a larger set of solar panels pushing about 55 volts DC. If you're familiar with my past work, I've been modifying electric space heaters to run off of about 55 volts DC and directly attached to solar panels, and that's been very successful. This, however, is a way to make a heating element without having to rewind coils of wire, and it allows some very interesting techniques. Now let me show you what you can do when you have a heating element like this. Okay, I'm back. This time I have a single 100 watt solar panel that's outside of the workshop, and that's actually powering this heating element here. It's only doing 3 watts at the moment, but now I'm going to show you why it's so interesting to have multiple segments to a heating element. You can actually remove the clip and you can switch it in up here somewhere. Look how quickly that changed. Look how fast that happened. So let's try switching 2 diodes out of circuit. Look at that. A variable solid-state heating element that allows me to switch anywhere I want to get any amount of power that I want. 9 watts. Once it warms up a little bit, it produces more power. 4.6 watts. So let's try going up to just one diode. 7, 9. It's trying hard to get to 10. Let's try switching one more diode out of circuit. There we go, 16. So what am I doing here? I'm actually trying to find the solar panel's maximum power point. 17 watts. Let's try coming up here. 51 watts. 52 watts. Let's put one more diode in the circuit. 49. Let's try This one, 53 watts. Okay, I've just found the maximum power point. You see how this PV voltage collapsed there? There's the maximum power point. Now, of course, I'm using a very long set of wires here, and that's part of the reason why the voltage is so low. But these panels I'm using are kind of low. Yeah, let's turn on the fan. These diodes do get pretty warm. 44 watts, 15 volts. So why is the voltage so low, 14 volts, on a 12-volt solar panel? The reason is it really is attached using a long set of wires. So let's go ahead and connect this at the far end. And let's use my test clips to do the switching. 11 watts, 10 watts. Let's switch to right here. Alright, of course this piece of wire that I'm using has a bit of resistance in it, so that's not quite optimal, but it's okay for a bench test. 51 watts. Let's check if they're overheating. They're pretty warm, but they're not overheating. Now if I turn this fan off, that's a different story. I'm sure they would overheat at some point. 52 watts. Let's try adding one less diode. So the point here in switching the diodes in and out of circuit is that it's possible to precisely match the solar panel's voltage at which it develops maximum power by changing how many diodes are in the circuit. In fact, the cool thing about diodes is that they, generally speaking, drop about the same amount of voltage, so if you match them properly to the solar panel, they will somewhat hold their voltage at the correct level for that solar panel, and the current will be what changes and varies the most. In theory, that's how it works. This is completely different from a normal resistive heating element. With a diode, it takes very little voltage change to increase the amount of current and drive more current across the junction. Seems like I'm stuck around 55 watts, but through a long wire and with winter conditions, that's not a surprise. Let's see if we can get a little more. Nope. I think I'm stuck at 55 watts. Let's try this one. 56 watts. Right there where my finger's pointing, I've switched out a number of the diodes out of the circuit. And that got me up to 56 watts. 14.7 volts, 07 volts, 4 amps. The diodes are getting a bit warm. So this is a PV to load heating element. Let's speed the fan up. Alright, I've sped up the fan. I can feel the heat coming off these diodes. I can't show that on camera, but there is absolutely a lot of heat coming out of these diodes. I mean, it's just coming off these things. Very interesting. This concept has promise. I'm gonna look into this and see what I can do to develop it. 56 watts. Now this fan isn't powered off of the same solar panels. It's powered off a separate solar panel because I don't want to interfere with my testing. Yeah, I wish you could feel the heat coming off the diodes. There's quite a lot of heat coming off of them. I'm surprised. I'm actually shocked. It works. Alright, so final thoughts in summary. This is something I'm going to be looking into more. I'm going to perform more research on this. It does work. I thought it would work, but I wasn't really sure what to expect, and I also wasn't sure how many diodes I would need. It's obvious that this is not enough for the solar panels I want to run. The solar panels that are going to be powering my heating element, if I build a bigger one, are going to be 10 times bigger, and I'm probably going to need a couple hundred diodes, which I was suspecting was the case, and I'm beginning to see that that is absolutely the case. However, it's not really a problem because the diodes are relatively cheap for what they're doing, and by using a network of diodes and using switching techniques to switch diodes in and out of circuit, you can actually fine-tune this heating element to match the voltage you're running at, and if you have any need to reduce the power of the heating element for any reason, to just dial it back, all you got to do is add more diodes in circuit. And remember, this is done in real time. Now another point to make by switching the diodes in and out of circuit is you're only switching a little bit of voltage, so it's really not a big deal. I can use these thin clips here to do that, it's not a problem. And it only matters how much current is flowing through. Now it's not possible to show heat on camera, but I assure you it was absolutely about 50 watts of heat coming off these diodes. I was actually able to feel it. You can't necessarily quantify heat by putting your hand in front of a fan, but the meter was telling me 50 watts. That power is going into these diodes. I know most of it's in the diodes and is dissipating there, so I know I'm getting 50 watts of heat. What I want to see is I want to see 500 watts. To get 500 watts, I'm going to run at a higher voltage. I'm going to use 2 or 3 times or even 5 times as many diodes. And I'm going to need to do something better than these terminal blocks. Those are really not safe and only suitable for a bench test. Folks, I was forced as usual to cut this video short, but here are the initial conclusions. It's a fact that diodes can be effective heating elements. Diodes are quite stable and predictable in terms of the amount of voltage that they drop, but they're very, very sensitive to current. In my tests, it was quite obvious that pushing only a little bit more voltage across a diode would cause a major change in the amount of current that was flowing across it, so this is something to keep an eye on. The fact that diodes are so stable in terms of the amount of voltage that they drop means that they can be matched to the maximum power point of a solar panel, or at least get close to it. And once that's done, the diodes can more or less hold the same voltage without using any additional electronics, in theory. Cooling is going to be the most important and difficult challenge with using diodes as a heating element. If they get too hot, they will fail, and that is a fact. I hope this video helps you out, and if I can do any more work on this topic, I'll definitely share my results. Thanks for watching, and I'll see you next time.